We copy you down, Eagle.
In the past century, astronauts have ventured as far away as the moon and have routinely orbited the Earth. But still, there is a vast amount of our solar system that has yet to be explored. In order to move forward, researchers are hard at work dreaming up technologies to keep astronauts safe and contemplating ways to meet the challenges of deep space travel.
Deep space travel has some very unique requirements. You have to first think that the spacecraft is going to be in space for a much more extended period of time. Reliability becomes very important for those lengths of time. It's exposed to radiation for a much longer period of time, so radiation effects have to be mitigated to a greater extent. And as you move further and further away from the sun, the power source becomes weaker and weaker. And so low power design, as well as low power operation and sleep modes, have to be incorporated into the design.
Radiation hardness is the act of making electronic components and systems resistant to damage or malfunctions caused by ionizing radiation, such as those encountered in outer space and high-altitude flight.
Well, radiation hardness is important in spacecraft because there is a background radiation in space. It's a very harsh environment. It has both the incident radiation as well as background radiation. So in order to design a spacecraft, we take a multi-level approach. It usually has 3 levels. One is all the way from the process that's used to build the components. That has to be physically designed in order to withstand radiation effects. Then we do circuit design, or what's called radiation immunity by design. And then we do system design such that the system can, even if a radiation effect happens, we can actually mitigate it through the architecture of the system. So we have to design it to be immune to these different environmental characteristics. The analogy is if you were to have an iPhone, it works fine in your everyday walking around, but if you were to try to use it underwater in a harsh environment, it wouldn't work at all.
For the past 55 years, Microsemi Corporation has played an integral role in hundreds of space initiatives, and its technologies have been used in a wide variety of space programs globally.
Microsemi has participated in a number of programs over its 55-year history, starting all the way back to the Atlas program in 1957 up into the most recent New Horizon program.
With a long-standing commitment to the space market, Microsemi has one of the most comprehensive and complementary space-related product portfolios in the industry.
Microsemi has a very comprehensive portfolio of products that include analog and digital technologies addressing a variety of systems-level space applications. FPGAs are field programmable gate arrays. These devices allow the designers to skip the manufacturing process and actually come to market faster.
The company's advanced technology and high reliability products have been used in many applications that require high levels of radiation hardness for trips to the Moon, Mars, and beyond.
Microsemi's business is reliability. We've been designing reliable parts for space and other applications for more than 55 years. It's in our DNA. It's not something that you do at the end. It's a process that you start at the very beginning with components, process selection, all the way to the architecture of the end product. We have to look at the reliability all the way across it and then test to verify that you actually did design it at the reliability levels that you were hoping for.
In addition, the company offers leading-edge system solutions for communications, aerospace, industrial, and defense security markets.
Realize that impetus for growth in the spacecraft industry is mostly in the communications area, internet as well as voice and video. In order to do this at a cost-effective way, we have to increase the capability of our spacecraft in data and bandwidth. This requires us to use the newest technologies and implement them in the spacecraft in a very highly reliable way. We're using our FPGAs, our timing, as well as a number of different powering methodologies that allow this higher bandwidth to be there for the needs of the Earth.
Microsemi's architects specialize in system-level integration, working with its customers to design the latest space-related products and technologies.
Well, as you know, the key to solving problems is the good engineering staff. Microsemi has one of the best, if not the best, engineering staffs in our industry. We use that talent and their capabilities and the procedures and processes that we have in place for our design methodology in order to solve these problems timely and completely.
With products that are qualified to the highest government, NASA, and European Space Agency standards, Microsemi continues to innovate in areas such as semiconductor integrated circuits, advanced packaging technologies, and leading-edge system solutions for precision timing and power distribution on launchers, satellites, and other spacecraft.
Microsemi protects its customers' investments in 2 important ways. The first is our ability to cost effectively produce the devices, and we're able to do this because we're a major player in this market. We can share technologies across different devices, customers, in order to get cost effective results. The second important way is we're able to produce parts for many decades, which is required in space environment. We are able to do this because of our special relationships with our vendors as well as our partners.
Microsemi is very focused on its continued commitment to innovate within the space market. We're investing in our R&D efforts within technology and our capabilities and the talent in order to further push the boundaries in this market.